a learning outcome 4. Under learning outcome 4 of managing risk and supply chain management, we're going to look at contributions project planning can make to manage risk in supply chains. Right. So the main outcomes to this learning outcome includes planning, identifying activities, estimating timings and costings, sequencing activities, applying critical path analysis, and developing Gantt charts and baselines. Right. So we're going to start with what is called a project plan. We were looking at these elements. So the elements of a project plan include the overview, objectives, general approach, contractual aspects, schedules, resources, personnel, risk management plans, and evaluation methods. And we've described each and every element thereof. Moving forward, let's look at the importance of project planning. It enforces those involved to consider potential risks and vulnerabilities. It identifies the deliverables, likely duration and cost of the project. It determines the resources that will be required at each stage of the project. It allows time for an estimation of cost quoted, challenging of business needs and over specification, and so on. It also identifies the tasks to be undertaken, the sequencing and timing within which they need to be undertaken, and any dependencies between tasks. It underpins control processes such as setting phases and milestones, defining responsibilities and requiring authorizations. It provides for end stage or gateway reviews. It specifically establishes budgets, targets, and timescales. It provides tools and outputs which make project success factors, milestones, and risk visible to all project participants and stakeholders. It supports management by exception. It allows the needs, views, and interests of project stakeholders to be taken into account in planning, process, and deliverables. It is very important. Moving forward, we do have under project planning what is called a work breakdown structure. This work breakdown structure simply splits out the work. For instance, we've got a robot which is designed, which should have manufacturing, electronics, and system design. Then each and every job is split into tasks like level 1, level 2, level 3. Moving forward, we do have what is called sequencing activities. When you talk about sequencing, we're talking about dependencies between activities which should be sequences. Some activities will have to be completed before others start because they provide inputs to the subsequent activities. There should be interactions between activities where some activities are linked to other activities, though not necessarily dependent, for example, because of the shared use of a limited resource. Resource requirement of activities. If resources are available, some activity may be undertaken concurrently, while if resources need to be transferred from one activity to another, they will have to be undertaken consecutively. Then durations or timings of activities affect the extent to which activities can be carried out concurrently. Right. Then we've got techniques for estimating time. We've got the bottom-up estimating, where larger breakdowns, break larger tasks down into detailed tasks, then estimate the time needed to complete each one, and add individual tasks together to derive a time for the project as a whole. We also have a top-down estimation, where we develop an overview of expected timelines for the whole project using past projects, previous experience, or expert opinion as a guide. Then comparative timing or estimating, we use the time taken to do similar tasks for other projects. Then parametric estimating, where the time required for one deliverable is estimated, then multiply it by the number of deliverables required. Then the 3-point estimating, where you develop a best case, worst case, and most likely case estimate in order to take account of uncertainties and contingencies. Right. Let's look at the key benefits of a network analysis or a critical path analysis. Then first, the need to think clearly about project activities, their interdependence, and estimated durations. The focus of attention on critical activities, those for which there is no slack time, allowing project managers to maintain a constant check on project processes with cross-project feasibility for the depends of all key activities. Right. Let's highlight on crashing activities. These identify activities that may be crashed. For each activity, establish costs, estimate activity duration with resources added, determine revised completion date and cost, recalculate critical path and costs, compare various options to determine most effective solution. Right. Causes of schedule variances. What makes differences to happen or variances? The first one is time estimates for activities contain uncertainties. A given activity usually takes at least the time allowed for a delay in one stop is passed on into full to the next step, whereas an advance in one step is usually wasted. Most people are required to do more tasks, increasing the lead time for all the activities they engage in. People may include safety margins in their schedule estimates. Right. Let's look at critical path in project management. What is it? What is this critical path? A critical path in project management is certain tasks that need to be performed in a clear order for a certain period. If part of one task can be slowed down, postponed, or a term without leaving work or others, then such a task is not critical, or tasks with a critical value cannot be delayed during the implementation of the project and limited in time. The critical path method is an algorithm for planning, managing, and analyzing the timing of a project. The step-by-step critical path method system helps to identify critical and non-critical tasks from the project start to completion and prevent temporary tasks. Critical tasks have a zero run time reserve. That means the estimated time should be equal to the earliest start time and the finished start time should be zero, should be the same. If the duration of these tasks change, the terms of the entire project will be shifted. That is why critical tasks in project management require special control and timely detection of the risks. Right. Let's look here for a simple critical path model. A critical path imitates events and activities in a project, presenting them in an interconnected network. Activities are rendered as nodes, and the beginning and the end of the activity look like arches and lines between nodes. The key stages of a critical path method. It involves 6 consecutive steps. Number 1, identify activities. 2, identify sequences. 3, create a network of your activities. 4, determine the time intervals for completing each activity. Then 5, find a critical path. The longest sequence on the critical path is the one which is considered. We do have what is called early start. This is the time when all previous tasks are completed. Then the early finish, which consists of the nearest start time and the time required to complete the task. The late finish comprises of all activities that are completed without postponing the deadline. Then the late start time is the latest end time and the time it takes to complete the task. These can be computed. Then this critical path can be used in line with what is called a Gantt chart. It's a visual scheduling tool, a graphical presentation of information which show dependencies between tasks, personnel, and other resource allocations, which track progress towards completion. Right. Let's just simply look at this simple example of a project of building a house. The activity number 1 is design a house and obtain financing, where the duration is 3 months, no predecessor. Number 2 is lay foundation, 2 months, no predecessor. Order and receive materials, 1 month, and predecessor is number 1. Build a house, 3 months, predecessor is 2 and 3. Select paint, 1 month, 2 and 3 is predecessor. Select carpenter, 1 month, predecessor is 5. Finish works, 1 month, predecessor is 4 and 6. Using this project, we are able now to do a Gantt chart for this house. As you can see, the design house and obtain financing takes us that period, the first bar, which overlaps, which is taken over by laying foundation. The foundation and order and receive materials can be done concurrently, but building a house can cross over to the 6th month to the 8th. Selecting payments and selecting carpet. We start by the painting, then the carpet, then the finishing work is the last. Hope you understand. Right. The Gantt chart for the job progress can be stated like that. Now we're looking at the inside apparatus, the table, the shelf, the kitchen units, and the bed. Right, the Gantt chart shows resource requirements. For instance, task A, task B, task C, task D. As you can see, the resource requirements are illustrated in those circles. Right. Let's also look at the Gantt chart in terms of its benefits and costs. When you are looking at the Gantt chart, you can establish a time-phased network. It can be used as a tracking tool. The benefits are it is easy to create and comprehend. You can identify the schedule baseline network. You can allow for updating and control. You can identify resource needs. Right. Let's look at organizing work packages the efficient way. They should form a meaningful, manageable chunks of the whole project for the designed individual or team. They optimize the use of available resources by grouping together tasks that share resource requirements and require shared specialists or experts. They minimize the need for coordinating mechanism within work packages. Allow attention to be given to coordination between work packages. They can be regarded as a single area of accountability as the responsibility of a single manager or team leader. Going forward, let's look at perhaps a class presentation here, where there should be a forming, the storming, the norming, and the performing. So this one you can practice in groups. Right. Let's look at further stages in project management, project team development. There's doming and mourning or adjournment. Then let's cross over to control systems. At what point in the project will we try to exert control? What factors are we trying to control? How do we measure the factors we seek to control? How much deviation do we tolerate before we intervene? How can we spot potential deviations before they occur? Right. The post-control, the project objectives. You have to identify the extent to which objectives were met and the causes why they were not met in full. There's the issue of milestones, or checkpoints, or budgets. Significant deviation from these predetermined targets should be identified and explained. The final report on the project's results. This should highlight significant deviations from plan, both good and bad. Recommendations for performance and process improvements. This is a valuable tool for improving future project performance. Right, let's look at project control methodologies. We do have various types of methodology for the end stage assessments, highlight reports, checkpoints, project plans, techniques such as project budgets, Gantt charts, and network analysis, complex project management software like MS Project, which can be used to manage a project. Right. Let's look at the progress tracking metrics. We've got the issue of percentage of completions. The advantage, it is easy to understand. It lends itself to aggregation, resource management, and EVA approaches. However, it can be subjective, inviting creative reporting and conflict. Another metric is remaining duration. Let's say a project is happening, then all of a sudden you just check how much is remaining in terms of time. It can be used as a metric. It is a practical approach. It is motivational. However, carries no implication for resources or cost deployed. It is too simple. Then another metric is the actual start or finish. Very simple to use, no room for subjective assessment, easy to collect information. However, little or no precision in relation to tasks in progress and acceptable for any significant tasks. Right, let's look at categories of problems. A problem may require immediate response or conditioned reflex, perhaps because someone is threatened with physical danger. A problem may range as a crisis. Unless we do something very soon, there may be serious adverse consequences. Some problems range as emerging, where something undesirable seems likely to happen unless we take action in advance. Some so-called problems are actually opportunities. We take advantage and convert potential loss into gain. Some problems have a long time scale. By formulating a long-term strategy, we can forestall adverse consequences and or take advantage of opportunities. Right. So basically we can come up with what is called a fishbone diagram, where we've got the management of team, specification of software, hardware, people in action. Then we've got software delivery date, late. Then we've got all those other aspects which can be incorporated in the analysis. Right, let's look at reducing project duration. How do we reduce project duration? Right, the first way is to review and challenge individual task duration, especially for tasks on the critical path. Analyze the logic of activity sequencing to see if some tasks can be carried out in parallel, or if the project can be simplified or reduced in scope. Authorize over time, additional work shifts, or so on and so on. That stuff accomplish more in each work day. Increase resources, either deploy more staff or seeking additional people or equipment where capacity has been reached. Reduce quality without impacting on fitness for purpose. Right, we can also use this diagram as a change control system. This diagram is usable. We are looking at the progression of a project and how you should control it. Then the issue of documenting the project. This is also an important aspect of the project, to provide evidence that the project has been completed in a proper manner, to give the client guidance on operation and maintenance of the output provided, to provide a good start point for any similar project in the future. Then issuing the final report. Right, in the final report there should be project performance, a comparison of what the project achieved with what it tried to achieve. Administrative performance, a summary of how well the administrative aspects of the project were handled. Organizational structure, including comments on how the structure helped or impeded the project of the project. Project and administrative teams, a conventional summary of the performance of individuals. Techniques of project management, a summary of how well the project performed in areas of forecasting, planning, budgeting, scheduling, resource allocation, risk management, and control. Right. Then there's the issue of review and audit criteria. The criteria can be divided into financial, time, quality, HR, environmental, planning, and control, of which we've got various audit ways like accounting systems for financial, conformance to plan, that in time, quality procedures on quality, conformance to policy on HR, conformance to policy on environmental, conformance to plan in terms of planning, systems for control in terms of control. Then we also have to use a review criteria like return on investment, cost variances for financial, customer satisfaction for time, customer perceptions for quality, team spirit and motivation for HR, environmental impact assessment for environment, cost techniques used, planning basis for improvement, that is for control. Lastly, let's look at the performance improvement. After finishing a project, there's an audit and review where we look at learning by doing or learning before doing or issuing of external knowledge, or which can lead us to another project B. Thank you for listening to this LO. This is the end of our presentation.